Okay, so I think we can start. Okay, so dear colleagues, guests, and participants, my name is Vitaly Kulanov. We, along with my colleague Artem Perepelitsyn, will moderate this session today. So, welcome to the DESSERT' 2023 conference. I'm thrilled to open our plenary session on hardware as a service. Today, I hope we will dive into a fascinating topic that's transforming how we interact with technologies. We have a lineup of experts who will share their insights on this evolving landscape. I also encourage you to actively participate, ask questions, and connect with fellow attendees. Thank you for being here, and let's get started. As far as I understand, our first authors are not here, so let's start maybe from the second.
Yes.
And let me introduce our first presentation for our plenary session today. The topic is analysis of ways of digital rights management for FPGA as a service for AI-based solutions. Authors Artem Perepelitsyn and actually me, Vitaly Kulanov. So let's get started, Artem. Can you please start?
Yep. So it's pleasure to provide and share the results of the research of the results of different directions that are includes the direction of intellectual services and providing of AI solutions like some service, and at the same time the ways of creation of prototyping of solutions based on the FPGA. So this is some crossing of directions of creation of AI as a services and creation of FPGA as a service. But the problem in this direction is how to provide such solutions for the end user to allow the integration with the systems. And to ensure this possibility, it's important to take into account the ways of organization of protection of such solutions during the distribution. And because of that, we consider the digital rights management issues, and we will try to cover the possibility of ensuring of such issues during the development process, and we will consider also the theoretical ways of how is it possible to perform the uh, ensuring of such solutions with use of theoretical ways of ensuring and identification of the exact chip. So we will try to cover the following things in our report. But before the accessing to the direct results, I propose to consider the current features of frameworks of the ways of work of such technology to allow the normal execution of the projects. And then we will be able to conclude how those technologies can be used together with solutions that provides the ensuring of licensing processes or DRM processes. Well, so let's briefly consider the current status of the technologies. So one of the main possible feature of organization of FPGA projects that can be organized as a service is the organization of the runtime reprogramming of the chip. And in this case, for the end developer, the chip can be provided as some function that can be called like in C language call, like C call or OpenCL call. And in this case, for the end user, the entire computational process inside the FPGA chip is represented like some function that can be called um, each second, for example, or twice per second, or maybe one time per 10 seconds, but no longer, because the XRT or Xilinx runtime framework allows the duration of the computation no longer than 10 seconds or near this value. And this is the specific requirements of the operation system and the environment and drivers of the PCI Express card. So this is the revolution of the way of how the FPGA can be accessed, because traditionally or initially FPGA can be considered like some embedded systems that use some JTAG interface to allow the communication. But in this case, it's possible to perform the brief changes of the data between the components and between the host application, and it's possible to organize a fast communication between the elements, and it allows to perform really fast changes and calls of the chip. Okay, and everything is carried out by the XRT framework. In this case, it's necessary to follow the requirements of this communication, and it's happening like the encoding of the binary of the FPGA chip to the chip, initiating of the running of the chip, and returning back the data to the host. In this case, host application is connected over a driver and over this framework with with the operation system, and it allows the programmer to perform the communication with the chip, and it simplifies the process of creation of FPGA as a service. And technically, it allows to focus not on the communication, but just on the functions that can be implemented. And in this case, a lot of pre-built and preliminary created binaries for some specific AI execution can be placed to the or collected at site of the host application, where it can be launched during few seconds, and then it's possible to directly perform the execution of required application, and it can be organized remotely. And to ensure this possibility, the following languages are supported. And for the AI development, it's typically some frameworks are used, like TensorFlow and Caffe. And also the Python is most frequently used for AI tasks at the moment. And because of that, the modern development environment like Vitis support the creation of such solution with such processes. And to work with that, it's necessary to follow the mentioned process of optimization of AI logic to ensure the possibility to transform the model of initial AI project and to place it after the optimization, pruning of the unnecessary connections, quantizing of levels to transform from float point representation to fixed point, and placing to the DAC processing unit, deep learning or data processing unit, and this is a deep learning unit that allows to execute a lot of popular neural networks that can perform the implementation of the algorithms for popular image recognition and another kinds of popular AI solutions, AI-based solutions. Everything is executed on the digital platform created by this company. Actually, for the moment, it's AMD company, and all the software stack at both sides, host side for encoding and FPGA side for processing, allows to perform the acceleration. To do this acceleration, it's necessary to use powerful chips, sometimes with HBM memory, and there are a lot of chips, such like was mentioned during the previous report, the plenary report, and the chips that also allows to perform fast acceleration of AI solutions. And company propose the first purposes of the use of such fast FPGA accelerator cards are the acceleration of AI computation. At least for the moment, it's most interesting direction for such accelerations. And this card allows, for example, U55C as the next generation of U50 and U280 cards, the possibility to work with up to 16 gigabytes of on-chip memory with the ability to transfer up to 460 gigabytes per second. But the next chip and next card that already announced but not available yet allows the work with 32 gigabytes and doublet performance of this on-chip memory that allows to perform a lot of computations inside the chip, because this memory is directly placed in the same package as the chip, and use interconnects to perform the communication. And the installed in the data centers of such hundreds and thousands of such cards allows to perform the centralized implementation of the services, FPGA as a service, and AI with FPGA-based implementation as a service. But while it's possible to deploy everything, the most important question, how to ensure the light sensing processes for such projects, while the end user can use some third-party libraries and solutions and components of AI. It's necessary to ensure the ways to perform the control of execution to prevent some unwanted and unmanaged process of execution of solutions. And to ensure this process, it's necessary to solve the most important problem of ensuring the control of licensing process of such solution. And in this case, the aim is to find the possible ways of licensing and applying of such process to improve the ways of the digital right management processes for AI and machine learning systems based on FPGA. And to solve this issue, it's necessary to perform the following tasks: to analyze the possible ways of ensuring of DRM, find possible options to identification of FPGA solutions, to propose the most promising directions of possible DRM implementation for FPGA services that allows to identify the exact instance, exact chip of FPGA, and allows the execution or prevent the unmanaged execution. And of course, to provide the solutions with such implementations. So, based on that and based on the considered ideas, it's possible to analyze the structure of current status of AI as a service with FPGA implementation, where it's possible to place the FPGA chip as a basic level or layer of such computations that can be connected together at the FPGA card. And with this card, there is a built-in software, some software that allows the communication over the PCI Express. It called shell, some shell inside the protected part or static region of FPGA. And with this, exactly this part, the host application can communicate. The next level is actually the host PC or station where such cards are connected together, maybe up to 8 per one controller or even more. And at this level, we can obtain the FPGA as a service layer, where it's possible to organize the communication with such elements, with such host solutions. But above all that, there is a FPGA based artificial intelligence layer, where it's possible to perform the computations with the implementation of some elements of AI that is based on neural networks. So actually, this is the general classification of place of FPGA in such services. And to perform the protection of such solutions, it's necessary to find the ways how it's possible to identify exact chip inside this structure of the service. And to identify the exact chip, it's necessary to find the possible way how to do it, how it can be done using the traditional ways and ideas. And based on the performance analysis, the following ways of theoretically possible ways of identification of the exact chip were proposed. And they are starts from the commonly and widely used information like email address, user-based data, and phone number, some USB key like external component, then the set of information based on the system board like MAC address of the network, volume ID of the connected device, storage device, some information about the basic input-output system of this system board, and trusted platform model that allows the execution of some trusted processes. And this theoretical level is based on the exact PCB and system board with the chip. And next level is based on the board itself, the card number and part number of the board. And this information sometimes is available for the chip, but sometimes no. And it's not technically useful sometimes to use it, but it's necessary to take into account that this possibility exists. And the most interesting and most promising way of identification that really provides an ability to perform the identification of the exact chip is usage of physical unclonable functions implemented inside the FPGA, because the implementation of physical unclonable function allows to find and maximize the difference between few chips, two different chips provided and created in the same technological process. So it means that functionally there is no difference between those two chips, and functionally it's impossible to differ what the number of the chip, because all the tests will be passed at the same way with those two chips. But with use the technique of physical unclonable functions, it's possible to organize the identification of the exact instance of chips that functionally completely identical. And it's possible to implement with maximizing of difference of the delays between different parts of the chip inside the chip, between different passes inside the chip, with use the oscillating and comparison of some ring oscillators inside the chip, with use of multiplexers emulating of the memory, static memory, and with thus unstable and uh, maybe generating of a random number or true random number generating, it's possible to perform the identification or some probabilistic identification of such elements. And with increasing of number of such parallel registers and bits number, it's possible to maximize the probability of identification of such chips. But it requires the development, and it requires the running of the process inside the chip, of course. But some identification ways allows the identification without the running of FPGA implementation. So based on this analysis, it's possible to find the possible ways of such identification of the exact instance. But the some chips, some modern chips allows to use some built-in solutions to perform the identification of the chip that simplifies this process. It's not available for all chips, but some chips allows it. And it can be done using the DNA port. It's not the unique way of identification, but it's one of possible identifications. And it's also possible with use another ways like USR access. DNA port allows the 64-bit and 128-bit dependence on the exact implementation, communication with the chip, and it's possible to perform the reading bit by bit using the shifting of the information inside. But the limitation of the use of such DNA port inside the chip is the limited frequency to the process of activation of this component. It can't be faster than 100 megahertz. This is the limitation. And while the chip can run up to 500 megahertz, it's some significant limitation of the speed in five times of the final performance. But from the point of view use of overclocked modes of running of FPGA accelerators, while it's possible to achieve 700 of megahertz and even higher, it's significant limitation, and it's necessary to use PLL to clock this component if it's required. Another way of identification of the exact component is use the user access component, but instead of the DNA that allows to identify the chip die inside some part of the chip, and in some components there are 3 parts in same package. The user access is a part of the binary stream generated during the compilation, and the developer can assign the exact user access over the parameter to the compiler to provide the exact code of this build. So it's technically can't be used directly for identification of the exact chip, but for identification of the exact build version or the exact build instance, even for the same version. So technically it's possible to use this user access component to identify the exact binary even of the same version. But there are the same limitations of such component of use with a frequency. And let's consider the example of the use of the DRAM projects from the one of associated with AMD company that provides the digital right management ways for such solutions. And this company allows to perform the work with built-in kernels, and we will consider how is it working. But in this practical case, let's consider that this activation logic and the DRM IP or DRM kernel or kernel DRM controller, to be clear, also connected to the 86 bits port of chip DNA. And you can see that there is such connection inside the logic of this DRM controller. So this controller is connected to the chip DNA to allow the identification of this chip. The investigation of internal implementation of this controller, obfuscated controller, that use the standard of obfuscation, and this standard allows to perform such centralized obfuscation of the code, and this code then can build. This standard is IEEE 7035. This is the standard of encryption, while the developer can use this standard and then is capable to perform the acceleration of such solutions. Well, let's consider how is it implemented inside the chip. While you can see the 3 independent super logic regions connected together inside single FPGA chip, and each such block contains own DNA port, and there are few possible ways of implementing it. 1 second. Well, so let's consider the implementation of such approach of DRM. Use some centralized server that performs the communication with the host application and with the libraries associated with the DRM logic that use the hidden way of communication with the kernel, not the same as the user use. And to implement this possibility of communication, it's necessary to specify the exact basic address of the kernel to the host application and to the libraries, obfuscated libraries at the host side. Inside the FPGA kernel, the DRM component can be placed, and this component is also obfuscated using this standard, IEEE 1735. And the communication with the kernels can be happening over AXI for interface, and it's possible to connect any number of user kernels inside this logic. This way of communication is not documented, but it's possible to use such ways of communication because this company working intensively with a vendor of FPGA logic and FPGA environment, and they use undocumented or not published yet features that allows the communication of the DRM logic in the way that not available directly for the end user. But technically, it can be implemented in this way. And in this case, the protected DRM logic can be connected to end user component using the independent AXI for communication buses. It's possible to perform the communication with this kernel to provide the activation logic and to provide the usage event, and all this information will be passed directly to the centralized server. The deployment process of such solutions can be done with use of integration of the DRM component to the project. Then it's possible to build the environment with the host application, then place everything to the Docker instance, and then it's possible to publish this Docker image at the website of Xilinx or AMD with the application store. So that's why we considered the ways of DRM protection, and I will answer for all the questions that can be based on our current report. Questions, please.
So yeah, let's have this question session part. Do you have like any questions you want to address?
It will be interesting to share the experience of work with such DRM solutions, with AI solutions, with FPGA as a service solutions. So we will be happy to answer for all questions.
Okay, so if no questions, let's maybe then continue. Thank you, Artem, very much.
May I ask a question?
Yeah, sure.
You were talking about using FPGA for different purposes, like card number or email or USB. So I don't completely understand how that works. I mean, it's one FPGA, but with different unique possibilities for each of types. Yes, about that.
Okay. We tried to consider the possible ways of identification of the exact accelerator card installed in the data center. And each card, modern card, contains some interfaces connected to the FPGA chip over some integrated circuits that allows this communication, like interface. And on those cards, there are a lot of network cards installed, and of course the possible USB connectors. And in this case, we're talking about the possibility of use thus on-board, on-system logic to perform the identification of the instance of the project inside the chip. So we're trying to associate the exact instance, the exact FPGA accelerator card with some unique ID or some unique feature that allows to identify this instance to ensure that only one or few allowed parallel running instances of our application to protect the application, to prevent the unwanted use or unmanaged use of this application, to ensure the rights management. So in this case, we are trying to use the onboard features. And while the network adapters are available for FPGA, we technically can try to use some features. At least we can consider this possibility while it's theoretical analysis.
Yes, I now understand. Thank you.
Okay, you're welcome.
Okay, any other questions? Okay, so if no any questions, thank you, Artyom, for this topic, for this presentation. Now let's go to our next participant. And our next topic is Information System for Administration of Medical Institution. And I assume like our presenter is Yevgen Bershansky. Please.
Yes, hello. So let me share my screen. So let's start. Today, I would like to talk about information system for medical institution and mostly discuss possibilities of like creating infrastructure part based on cloud services and based on cloud architecture. And before we move on, I would like also to tell you about brief introduction what its medical system is, classification of medical and types of medical systems, some existing solutions, and compare some solutions of medical information systems. And after that, we will move on with proposed solution of information system based on cloud infrastructure. So medical information system is like software product designed for medical institution, and not only for medical institution, but for general or specialized medical institution and purposes. And it's mostly such innovative way to bring our medical medical sphere into digital transformation. So types of medical information is hospital information systems, radiology information system, laboratory information system, pharmacy, and picture archiving systems. And on this picture, you can see that we have all different types, and every type connected to patient information database. We'll focus on this a bit later. That we have database and all information system based on some patient information. So as I mentioned today, we will not talk about functionality of medical information systems, but mostly about infrastructure design and mostly about its performance and what challenges we have. It's system performance design during operation, efficiency with communication between databases in healthcare. So it's very important to take information from database really fast in order to work. And as you know, medical information systems, it's like specific unit of information systems. And we have like high cost of database management, because it's also should have like security layer and so on. Let's talk about some existing information systems in medical industry. I would like to highlight one of them. It's Dr. Alex. It's one of our Ukrainian product of medical information system, also based on cloud, but as it's private research and private development of company Alex, so we couldn't know what type of infrastructure and was used in order to develop this system. Also, we have two other information systems called Methods and MedElement. It's also based on cloud-based solutions and information system based on cloud. As it's also highly like confidential information to use medical and information. In publicly, we have short and limited information in order to compare this. Here we have short screenshots and like functionality. What we can see, it's like administration of different cabinets of a medical institution, some schedule, some patient information, schedule for doctor appointment, and so on. So let's move on to proposed solution. Proposed solution, as I mentioned, to like eliminate all of challenges, it's to use cloud technology, but not only cloud technologies, but use two different and combine two different cloud architecture. It's serverless architecture and microservices architecture. So what is serverless architecture? Serverless architecture, it's architecture where you have, in which you have like virtual environment runtime without needs of any hardware maintenance. And according to cloud responsibility model, everything for hardware parts, security patches of hardware, and so on, it's responsible cloud provider. And microservices architecture, it's architecture mostly for design applications, to split applications for several parts in order to have better performance of application and develop separately different functionality of one of system and applications. The main technical requirements are it's leverage serverless technologies and cloud load balancing technologies. Also use serverless database architecture. I will describe a bit later in next slide. And use cloud infrastructure at all, because cloud provides 99.9 reliability and availability of system. So it's one of a benefit to design cloud-based solutions. I would like to focus on next two slides. So on this slide, we have architecture solution diagram. And here we can see that we have different cloud services. And for example, we have in the middle of our diagram called AWS Code Pipeline. Also, I forgot to say that I decided to use for my development and research AWS, it's Amazon Web Services Cloud. And for developing application of medical institution, I choose CI/CD tool for deploy and build applications. It's called AWS Code Pipeline. Then after we developed our application, build it, then we are storing our application in container registry, because microservices architecture also based on Docker containers. And here we have two main components. It's ECS cluster. ECS, it's Elastic Container Service. And we have Fargate. Fargate, this service for deploying and applications based on serverless technologies. And it's specifically container-based and mostly used by microservices and such architecture. Also, we have second point of serverless. It's Amazon Aurora database, which has possibility to scale to 0. So, for example, if you don't have at midnight any traffic to system and so on, based on monitoring tools, it can scale to 0, and you will not pay for using of this database. Also, we have for application communication between application and database, we have AWS Secret Manager, which is responsible to store database login, password, and some connectivity parameters. And let's move on. So next one, we have infrastructure solution. So this mostly related to network solution. As you can see, we have public part and private part. So public part, we have here with public subnet, consists of public subnet. And on top of public subnet, we have application load balancer. So when user came from internet, it goes to application load balancer, which has also security features. And the main purpose of this load balancer to balance between several application replicas, copies, I would say. After that, our request come to public subnet, and from public subnet, it came to private subnet. In private subnet, we have our application microservice layer, and it's for security reasons. We have this public subnet, private subnet. So regular user couldn't connect directly to application without getting to application load balancer. So. And after that, we have separate database private subnets. It's for storing and deploying database in cloud. And as I mentioned, we have Amazon Aurora serverless service for deploying database solution. And we have private connectivity between application and database. Here we have monitoring. It's Amazon CloudWatch and autoscaling. So based on monitoring data, we can scale up or down database and our application. So here we have combination of microservices and serverless technologies. So what is the results? On screenshot, we have one of examples of medical information systems. It's specifically for pets. It's like pet clinic, but such cloud solution can be used with any type of medical systems. And also we have possibility to schedule medical appointment, doctor appointment, and so on. So to summarize everything, I developed cloud-based solution for medical information systems. We deployed database as a serverless layer, which eliminates like security and performance issues. Also, we have load balancer to distribute our workloads between different application copies and to stabilize our like system and to have all operational support 99.9. We used a cloud provider such as Amazon AWS provider. Thank you everyone for your time.
Okay.
Any questions?
Yes, thank you very much. Any questions from anyone? Okay, maybe I have like a question from my side. So did you do any preliminary research which cloud provider you're going to use, like why AWS?
Yeah, thank you for your question. Yes, I did the research, and probably you know we have three main cloud providers. It's Google Cloud, Microsoft Azure, and Amazon Cloud. And I made my own research, and like this combination of microservice architecture and serverless, the best suitable is on AWS because container-based serverless functionality can be used only on Amazon Cloud. Google Cloud also has similar solution, but it's more complicated in terms of creation and integration.
Mm-hmm. Okay, and did you, so regarding, since you mentioned that this is like medical system, did you make any research to find out whether are there any specifically dedicated to medical services which are available for you out of the box from the AWS directly? So did you make this research before?
No, but they're providing mostly infrastructure, and you as an engineer can develop medical system. And they have some medical standards, for example, for databases, for storing data. So they are providing infrastructure solution, and but not exact medical systems. So in terms of answering your question, they don't have some specific medical services, but they have they are following standards for developing medical systems.
Mm-hmm. Okay, so thank you very much for your response. Any other questions from anyone? If no questions, then thank you very much, Johan, for your report. Now let's go to our next topic, and our next topic is method of repairing accumulators of portable electronics under limited resources. So,
Yeah.
okay, Artyom, you will be a presenter.
Yes.
So, yeah, let's please share your screen.
Okay. Thank you. And during this report, I will try to provide the results of a long chain of experiments and tests that are very actual and can help to a lot of people. And technically, this research is not only the part of this presentation, it's completely of a few different directions. But here we will try with our co-authors to cover the problems of recovering of some components of electronics, of portable electronics, and consider the ways of improving the efficiency of use of such solutions. Also, we will discuss the features and possibilities that provides the secondary good markets, and we consider the use of goods from secondary good markets, especially electronic, as a possible way of not only solving some complicated solutions, but also the ways of improvement of the ecology, so solving of problems of building of portable sources of power, and everything, all of that is based on the restrictions of limited resources. So technically, this direction is too interesting and too actual or relevant for the moment. But in this research, in this report, we will try to cover the problems of reuse and recovery of lithium-ion accumulators from the portable electronics. We will cover the analysis of voltages, ranges, and features of the popular cells, including 18650 version. Also, we will consider the ways of recovering and restoring and repairing of laptop batteries, including battery controllers and fuses. Also, we will discuss the ways and possible solutions of repairing of accumulators itself, and we will propose the sequence as a final scientific result of this research of recovering of such solutions, generalized with generalized steps that allows the following of this technique to repeat the recovering steps that will help in most of cases. And we will provide the examples of recovering of such controllers with use of external adapters and connectors over the local peripheral interface with reading of the memory of such controllers, and with updating the flags inside such controls. But before that, it's necessary to provide the results of our previous works and discuss of the features of lithium cells, lithium-based or lithium polymer and lithium-ion accumulators that typically has different elements and chemical elements, and thus chemical features define the maximum voltage and the allowed current of charging and discharging. During the research, we concluded that it's better to avoid the high current, and even if the documentation provides the information that it's possible to use the double current value, it's better to use only 10% instead of 200s. But the research showed that the maximum linear efficiency of the work of such cells at the allowed range is close to linear characteristic, and this curve turns to linear form, where the energy can be associated with the square of this figure. And based on the square under this line, it's possible to estimate the capacity of this, or lift capacity of this accumulator. But to estimate the lift capacity of the cell, it's necessary to consider not only the cell itself, but the model of the discharging, because it depends on the model. And if the model uses the constant power, it means that the middle value of the capacity will be a bit closer to highest values instead of the model with constant current. In the constant current model, the unused extra voltage values will be transformed directly to the heat. So instead of use of this extra voltage to transform it to some efficient way of use, it will be disappeared like a extra heating of environment. And in this case, a medium line will be based on some average value of the voltage of this battery. This is very important for understanding of the processes of discharging, and it's necessary to take into account during the considering of all possible solutions based on such elements. And based on the previous research, it was proposed the following combinations of voltages and combinations of sequential connection of the cells with voltage of 4.2 and 4.35 volts. But it's not only existing volts. There are another voltage ranges, and based on those considerations, we concluded that the magic numbers of the sequences are 3, 5, 7, 9, or 10, depending on the exact value, and 11 and 13. You know that some of those values are widely used, like 13 and 10, like the solution for electrical bicycle and another kind of transport. But for home sources, it's also interesting to use, because some magic numbers of sequentially connected cells allow us to obtain the voltages associated with some number of connected 6 or 12 volts of accumulators from UPS, and not only. And we can say that the numbers of 7 cells of lithium-based accumulators equals to 2 sequentially connected 12 volts accumulators, like auto accumulators. And it's necessary to take into account the same for 13, like 4 connected 12 volts or 8 6 volts. And it's also interesting that it's equal to voltage ranges of 96 cell solar power panels, and for 6 elements and 9 sequentially connected cells, it's equal to 672 cells, solar panels with 72 cells. But based on this analysis, it's possible to conclude that it's interesting to use the possibility of reuse the secondary good markets to perform the problem of usage of such cells with a price in 10 times less than the price of the new item, but it's possible with use of some sequences perform the recycling of such cells, and it will help to use those cells, and as it's turned out, their capacity not changed significantly even after 10 years of the use and long process of the storing. And because of that, the main goal of our research is to improve the efficiency of process of reuse of accumulators for portable devices. And to solve this, to reach this goal, it's necessary to perform the following tasks: to analyze the existing types of laptop batteries, to analyze different models of battery controllers, to analyze the possibility of repairing of lithium-based batteries, to propose a technique how to do it in the general sequence that can be reproduced by anyone, and to provide the example of the practical repairing of such solutions. Well, as it turned out, the lithium-based cells of different forms, including 18650, it's possible to use the classification, and it's possible to find in the community the ways of identification and specification for such cells with providing of capacity number of the ID of this battery, to identify it, to find the specification, to find the voltage and current characteristics, and so on. It's important, including the temperature characteristics, because it helps to understand the feature and the possibility of reuse of such cells. It's turned out that some of cells based on some laptop batteries included inside and produced centralized can be of very high quality because it's original product. And the logic of the laptop batteries controller can be blocked because of the over discharge. For example, the laptop was left with a sleep mode while it continued the discharging of battery. The battery was discharged completely. The logic inside the controller blocks the charging process of such batteries. And even with completely new accumulators that leave the capacity, leave the features that just never used, this laptop battery can be restored technically, and they will be directed to the recycling, and after and some parts of such batteries can be found at secondary good markets. And while they are incoming to such markets, available easily available for anyone, it's possible to organize this processing not in manual manner, but with some automation, with amounts of parties that measure it in thousands of batteries, not cells, but laptop batteries, to organize some automated processing. And in this process, it's very important to know and find the specification of such elements. And we propose to use the search, including the secondary live storage source, to identify such cells. It's interesting to add that such cells can leave their capacity because of the degradation feature of the lithium-based accumulators. The intensity of degradation, time-based degradation, is based on few parameters. The first one is the temperature. The second one is the voltage of this battery. And there are a third parameter, it's current, and also the number of cycles charging and discharging can take a part in this degradation process. But while there is no or just no memory effect in such batteries, this memory effect is detected, but it's not valid and it not prevents the normal working of such accumulators. The interesting thing is happening while this cell is discharged to under the limit of the controller, under 3 volts. The controller can apply the current to controllable fuse and destroy the fuse. After that, it's possible to use those cells using the proposed techniques that we will discuss. And in this case, it's possible to use such cells, but while the voltage under the minimum level, the intensity of degradation is too small, because the maximum intensity of time-based degradation is valid for the cells charged to the maximum voltage. It means that the cells charged to 2.75 volts and with disconnected from the controller because of the fuse, that cells can be lived, can be stored during a lot of years, up to 10 years before the recycling, with saving of their capacity. And this strange result is based on 2 things. Because of the low amount of cycles before the blocking based on some accidents like over discharging during the sleep mode of the laptop. And the third thing is a low voltage that prevents the efficient or some forced discharge process and process of degradation. Well, if this thing is happening, it's possible to perform the diagnostics of such cells. And while the fuse is not activated, while it's in original state, some cells, some laptop batteries can be charged externally to cross this low voltage. And it's possible to done with sequentially connected cheapest TP4056 charging controllers that is available at any store, just at any store for the moment. And it's necessary to use some independent USB power sources to perform the charging. It's impossible to use the same source. It's necessary to use a galvanic separated sources depending on the number of the sequentially connected cells. In this case, there are 4 cells and 4 sources connected over 4 boards of TP4055. And for some part of controls with unattached, with unchanged fuse, it's enough to perform the charging of such cells externally. After that, it's in some cases the controllers of the battery can detect this voltage and start the normal working without reprogramming, and it will help to restore and recover the battery for the laptop without extra actions. And in this case, it's possible to save the resources and to continue the usage of such element. But if it's not enough to perform the charging, while after the charging the controller is still can't be detected and there is no voltage on the external part of the connector of this laptop battery, it's necessary to check the fuse, and if it's okay, if it's not activated, it's necessary to attempt the following scene. It's necessary to emulate the normal discharging process, and this action can be done with connection of the positive side of this circuit and connection of this positive side to the one pin inside the connector of the battery over the resistor, or with some external load, for example, the cooler, or some load with current at this voltage of 12 or 16 volts, depending on number of cells, can be applied to obtain the current in range from 200 milliamperes to up to 1000. And after a few seconds of connection of the voltage directly from the most positive contact with this voltage to the required positive contact at the connector, to the load connected to the negative connector, it's possible to emulate the normal operation. And after a few seconds, the controller will detect the current. And for most of controllers, this manipulation allows to recover the normal operation of manually charged battery, to restore the operation of the controller without reprogramming of the controller. But while the fuse is not activated, while this operation was done, but the controller is still not responding, and there is no voltage on the output, and while the battery not detecting on the installed battery not detecting in the operation system, it's necessary to perform the identification of the controllers inside the chips. The performance practical analysis and the research of the existing controllers showed that there are a lot of different controllers and vendors of such controllers. And there are a lot of series of such controllers, including BQ300, 800, 80 or 8000, depending on the exact model. And it's necessary to find the required controller. But there are another series, including BQ 90 and 9000 and 9003 and so on. And depending on the exact controller, it's necessary to find the some documentation for this control to allow the normal process of recovering of such controllers, to know the addresses of registers and is it obfuscated and protected, because some controllers use encryption to prevent reverse engineering and prevent the restoring. Actually, this action is reasonable because work with lithium-based accumulators is too dangerous. It can cause a fire, and it's necessary to take into account that overcharging and all actions with the charging and discharging processes of such lithium-based accumulators requires the very careful execution and use of some extra preliminary protection against such cases. And because of that, such controllers are dedicated to perform the blocking of the cells that can potentially can cause a fire. And while we sure that they are blocked by some mistake, and the use of such solution is completely safe, we can continue such operations. And it's necessary also to take into account that to reduce the chance of overheating during the building of the solutions based on such cells, it's important to use the parallel connection of valid cells without self-discharging, and this helps to reduce the current over some exact cell. And while the degradation of such cells is based on the increasing of the resistance, internal resistance, it's possible to solve this problem by adding of such elements in parallel. And in this case, it's possible to decrease the resistance of the final package of such cells. And in this case, we will be able to use the original or just or near the original capacity even after a lot of years of the use of such cells, because of the restoring of the internal resistance by means of the parallel connection. So technically, in this case, while we will use the model of discharging based on the power, it will help us to achieve the highest possible capacity available even after a decade of the use of such cells. Well, let's provide us the practical result of experience of recovering of the exact controllers and batteries. Here you can see the versions and models of the controllers involved in the experiment that performed by our team. Thus, controllers can be found at the following vendors of the battery. As you can see, the same controller can be installed in different models of batteries, including well-known companies. And it's interesting that the same controller can be used in different laptop batteries. And for some controllers, you can find the market here lines was successfully applied the manipulation with the connection of the positive contact directly to the output line of the external connector. Sometimes it's necessary to connect two more contacts to allow the start of working of such controller, and it's also necessary to take into account. But for the following controllers, the experimental result of recovering was completely successful. The experiment for recovering of this controller was unsuccessful, and this experiment was repeated with 3 independent batteries from different laptops with this controller that was destroyed or blocked in different conditions and of different models, and it's possible to conclude that for this type of controller, this process of recovering is not working, so it's not applicable. For the rest, there is no results, and maybe the further experiments will help to understand is it acceptable for such controllers. But here the fuse was activated, so it means that this controller technically can be reprogrammed, but it activates the programmable fuse. So it actually fuses the fuse, and after that it's necessary to replace it before the usage. Well, based on the performance analysis, we can propose the following sequence or technique of recovering of the controller. And so this technique allows to perform the recovering of the controller in case while the fuse is inactivated, so it's valid, and there is an interface, I2C interface, to perform the reading of the exact controller to perform the recovering. And we propose the use of the following steps of the connection of the performance the sequence of the connection of the element and reading the required flux, restoring, turning the mode of reading mode, and switching from the boot mode. It's necessary to return back to allow the reading of the address, restoring the flags, and changing it back to allow the normal mode of this controller, and performing the actions of reading to ensure that it's valid and it's working. And while it's successfully done, it's possible to recover the work of the this controller to allow the normal work even after it was blocked. To perform it practically, the S7.1 controller was connected to the investigated controls over the external interface, and the results of reading of different controllers show the status of such controllers, and it's possible to read the information, not only the raw dump, but also the informative information about the status. And to do it, the modified version of console-based program was prepared and compiled. And based on this information, it's possible to read and perform the manipulation with the information inside the controller. This is a representation of the raw data from such controller. Sometimes it's obfuscated, but it's typically possible to perform the reading of the information where the number of cycles and extra information, including the manufacture date, is available. And here you can see the result of the work with the controller that was produced 23 years ago or even more. And based on those results, the practical experiment with discharging and process of recovered battery was performed on the Ubuntu for the exact or specific laptop with the exact battery. And it's possible to see the diagram of discharging that was done after the replacement of the cells. And it's necessary to take into account that during this process, some number of iterations are required while the cells were replaced manually. To do it, it's necessary to replace it in parallel. So it's possible to use a working controller and the cells from another battery that is working but with blocked controller. And it's possible to charge such cells to the same voltage and replace the such cells by the new cells with saving of controller. So this is the process of parallel replacement, while the new cells can be soldered, and then the old can be unsoldered or unconnected only after the replacement by the new, to maintain constant voltage and the voltage level at each pin of this controller. But after that, some number of cycles are required to recalculate dynamically the capacity of such new package and new replaced batteries. And because of that, sometimes this controller can calculate or estimate the lift capacity incorrect, and because of that, some number of cycles of charging and discharging is required. Well, based on this research, the following results are obtained. The analysis of the lithium-ion voltage ranges, accumulators, ways of the reuse of the second good market was performed, and also It's proposed the ways of diagnostics and fixing of such batteries. It's proposed to use such cells in parallel to decrease their internal capacity while they are used, and it allows to continue usage of such cells with self-discharging to build the automotive power sources. And also it's the analysis of controllers for such solutions was performed, the ways of reprogramming and recovering and restoring of such batteries for portable electronics. It's also it was proposed to perform the manipulation with the power sources and connection of external line to the positive line with emulating of load to recover such controllers and batteries while the fuse is not activated. And it was proposed a sequence of recovering of such solutions. Well, based on this sequence, it's possible to perform the recovering of such laptop batteries to allow the longer life of such solutions and to reach the initial goal of this research. Thank you for your attention, and we will be happy to answer for your questions.
Yeah, thank you for this very interesting topics. Do we have like any questions?
Please.
Yes, please.
Good day. Thank you for your presentation. I have a question. How many time we have to spend on recovery of these batteries?
It depends on the knowledge. During the research process, the 9 years of experience or even more years of experience was included. But the time is required for obtaining the knowledge how to perform the recovering. But if the sequence and knowledge is ready for use for exact controller, it requires a few minutes with available sources and tools. While this everything is available, based on the proposed sequence, it's possible to perform such steps with time of up to 30 minutes or less to perform the diagnostics, and maybe a few hours to perform the recharging of the battery, and it's enough to perform the recovering actions.
And one more question. In the modern laptops, we mostly use lithium polymer batteries and accumulator. Have we a reason to recover all the batteries like 615 for old laptops, or we can just use a new cheap laptops?
Okay. Actually, in this analysis, not only 18650 accumulators were considered. The lithium polymer and the accumulators of different forms was tested and recovered also. For example, this line and this result is for recovering exactly for lithium polymer batteries. And actually, the difference is only here in the form of the or shape of these accumulators, and it applies some extra requirements to the technical protection or physical protection of those accumulators, but the process of recovering is the same, and the exact chip can be found add both types of accumulators, does not matter. Is it external or internal or replaceable or not replaceable accumulator? The chip and controller can be the same, and the process of recovering is also the same. It does not matter what type or what the layout of this accumulator is for the exact version of the laptop. So it does not matter, but to simplify the example, we considered exactly the example based on the 650, sorry. Okay, thank you.
Thank you for your answers. No more questions.
Okay, do we have any other questions?
Okay, thank you for your attention, and it was a pleasure to discuss it, and I think that we finished with this report.
Yeah, and basically we finished our session as well. So thank you for all of you to be a part of our session, and let's see you in our next activities. Have a good day.
Thank you. Let's wait of the starting of the next announced activity in a few minutes. Thank you.
Yeah, we will continue our plenary session at this site. Hence, please be here, and a few minutes later we will continue our work. I see dear Andrei, dear Adam, nice, dear Ray, nice to hear you and see you. Andrei, please switch your microphone. Switch on your microphone. Now we are finishing our parallel session to other groups, and after that we will.
Are you there? Okay, so have you joined? Okay, because we are waiting for you. We are waiting for you. Okay. Okay, thanks.
Andrei?
Yes, I'm here.
Okay, it's nice. Please wait a few minutes, and now Professor Bardis will join us. He finished parallel session, and he come. Please.
Yeah, I just called Ed, and he would be joining us in 2 minutes. So, okay. We should be available, all of us, and also other people. Thank you very much for your help with the connection, and I'm hoping that other people are going to join us as well, despite late.
Okay.
So,
Hence, after short welcome words of Professor Bardis, you can continue with your presentation, and we wait for.
So is it okay to switch the presentations, and after Professor Bardis is going to have his speech, can we start with Adam first, and then have Ted? Is it okay? Vava, can you hear me?
Yes, it is your decision. Okay. What is?
So, Adam, could you be kind enough, and after the introduction from our host, could you start, please?
Oh yes, but maybe
okay. Sorry, please wait a few minutes.